Hi Year 11. In this little revision video, we're going to be looking at three topics. The first one is IDEs, or integrated development environments. These are the programs that we use to do our programming. For example, Genie is an example of a IDE. We're going to look at translators, and this is the program that will take the source code that we write, the code that we write on the computer, so like Python code, and it will turn it into machine code that the CPU will understand. We'll also look at two types of language known as high-level language and low-level language. There's quite a lot of technical facts in this one, so it's really important that you have maybe flashcards written for this one, and your homework will be to make flashcards on this to help you learn some of the details. So the main purpose, when we write code in Python, the computer will not understand it. Okay, it's written for us mainly. So we are writing down our coding ideas, and we need it translated into something the computer will understand. So the code we write is known as source code. Source code is code like in Python or Java or C++, where we will write commands such as input, print, if, while, and things like that. A translator will then translate it into machine code, and machine code is written in binary. This is ones and zeros. So each instruction that the CPU understands will have a different binary number or opcode, and the translator will basically take one line of our code in source code and turn it into many lines of machine code so the CPU can understand it. It is a bit like if I was trying to talk to someone who speaks French, for example, I will probably need a translator to help me talk to them. So someone will then translate the English that I'm talking into French for the person I'm talking to. There are a number of key features of an integrated development environment. You will have a code editor where you can edit your code. So this is where you can type in your program. You will have syntax highlighting, also known as pretty print. And this is where it will highlight different parts of a command in different colors to let you know and to help you with your coding. You'll also have an opportunity to maybe translate and run your code, and this will allow you to test your programs inside the IDE without having to open up a separate program. So editors allow you to write code in human readable language like Python. Syntax highlighting, also known as pretty prints, makes the code easier to read by highlighting different parts of the code in different colors. For example, strings will be highlighted differently to an integer. And then compile and run will turn your source code into machine code, which is understandable by the CPU. Yes. So one of the things it does is it will give you error diagnostics. So when you type some code in and it doesn't work, you'll get an error. For example, here I've got an error in my code. I put print instead of print. So that's a syntax error. So it will then tell you what the error is, where it thinks the error is, and what file it also thinks it's in. You will also have an interactive run environment. This is where you can test out ideas immediately without having to write the program fully and then press run. So you can just try out quick calculations, quick ideas, just to test to see if they're working. When a program runs, it will set everything up. It needs to run it, to execute it. And once it does that, that's called the runtime environment. We can also then interact with it, and that's known as the interactive environments. So when we want to run our programs, the translator will need to take the code, the source code, and turn it into machine code. When you do so, it will turn it into code which is very, very different to what we're used to. It's going to take a high-level language and turn it into a low-level language. On the screen, we have an example of a low-level language. So this is some of the kind of assembly code that Python will produce. And this is just kind of giving you an indication of just how different it looks. So it is very different to a simple print hello world, which is what this is doing. And it's also doing some print of some numbers as well. So the high level version of this code is on the left, and this is our human readable code. On the left you have the machine readable, the assembly code, and this is low level. You can still read it, however it's much more difficult to understand and therefore much more difficult to code with. This is why we will prefer to code in a high level language like Python, and then we don't have to worry about all the technical details of a low level language. The only time we will use a low level language is if we don't have a compiler or translator available in order to do so. The key differences between a high-level language and a low-level language are that high-level language is readable by human, whilst low-level is less readable. Okay. The next difference is you do not need to know about all the different registers inside the CPU in order to write Python code. Okay, you can use variables to store values. You don't have to worry about I don't know if it's going to register 1 or is it using the MAR or the MDR. You don't need to worry about that. With low-level languages, you do have to manage the registers yourself. You have to decide what value goes into what register, which means you need knowledge of how registers work, what registers are on the CPU, and those kind of technical details, which is obviously a much more tricky thing to do. Source code can be run on many different types of computers. So what I mean by that is you might be able to run it on a Mac or a PC or mobile phone and things like that. Formally, we say there are different CPU architectures. So the type of CPU you will find in a phone is different to the type of CPU you might find in a laptop or a desktop computer. Low-level languages, however, they're designed to work only one type of system. So you will only be able to run on one CPU architecture only. You will be using the commands that are very specific to that CPU architecture, and therefore it won't work on any different ones. When you translate code, source code into machine code, there are three main ways of doing it. We have assemblers, we have interpreters, and we have compilers. Each one of those will do it ever so slightly differently, and we use them for different purposes and reasons. Compilers are where we will take the source code and turn it into machine code in one go. We'll then have one file containing all of the machine code that I can then use to run. We only compile it once. If I do have errors, then it's shown right at the end of the translation. Interpreters are, in contrast, will compile one line at a time and then will run the code immediately. So they'll translate a line and run it, then translate the next line and run it. Every time I want to run my program, the source code needs to be interpreted again. This can slow things down. However, one of the big advantages is that when it does find an error, it will stop immediately and tell you where the error is, which makes debugging the code a lot easier. Assemblers are a special type of translator which only work on low-level languages like assembly. It will take assembly language and turn it into machine code. Again, it only does it once, and each assembly instruction is equivalent to a machine code instruction on the CPU. So that's the three main parts of this session. If need be, do watch over this again or watch some GC pods if you need further details on any of those three topics.